So hi everyone. I will do the introduction, but I just need to play this very short video and then we can start from there. So I'll share my screen with sound. So give me a second.
Hello, deep learners. I'm Andrew Ng, founder of deeplearning.ai, and I'm excited to welcome you to our global deep learning community. I know that many of you are here today because you want to break into AI and build your career. I hope that being part of this community will help you to do so. To give you a proper welcome, I'd like to show you around the deeplearning.ai offices and meet some of the teams so that you can see where it all happens.
Oh, hi, Andrew.
Do you want to tell our friends at Pine AI what you do at deeplearning.ai?
Sure. Hi, everyone. I make articles and other media that help people learn about AI and help them understand the huge impact that AI is having in the world. Today, I'm putting together the next issue of The Batch, our weekly newsletter, and I'm looking for the biggest stories of the week to keep our readers informed.
What's been the most surprising thing you've run into working on The Batch?
How much is going on in this field? There's never a dull moment. You might think from the outside that machine learning engineers really understand everything about AI, but nobody understands everything about AI because this field is just coming to life right before my eyes as I put this thing together every week.
All right, I know you're really busy, so I'll let you get back to it.
Thanks. See you later.
Let's go meet Kian, who helped me create the deep learning specialization. He's working on an exciting new project. Hey Kian, so do you want to tell the people at Pine AI what you're working on?
Yes, sure. I'm leading a project called Workera, focusing on helping people get offers in AI and navigating their career by testing their skills, preparing for interviews and certifying them, as well as matching and referring them to good jobs in AI.
That's really cool. And what's the most exciting part of your day?
You know, the AI field is new, organizations and jobs are still misunderstood. So I'm excited to help people understand what different types of jobs exist in the field, what tasks they will work on, and what skills are needed to achieve those tasks.
That's really important work. Well, it's nice chatting. And now let's go chat with Hotel, who is on their product team.
Hey, Andrew.
Do you want to say hi to our friends at Pine AI and let them know what you're working on?
I would love to. Hi, everyone. I lead the product team in deeplearning.ai, where we create AI education content accessible to people all around the world. People like you.
And what are you most excited about right now?
I am so excited to see our community grow and to see how eager people are to learn more about AI.
Thanks, Hotel.
Thanks, Andrew.
So as you can see, our team is working hard to support you and help you learn. It's never been easier than before to break into AI. So if you want to build a career, you can leverage online resources available, including open source code, datasets, papers, and online courses like a deep learning specialization on Coursera. As part of this journey, I hope you get your hands dirty too. Don't be afraid of diving in to build your own project. Or go ahead and try to replicate a research paper that you're excited about. One thing that I've seen help a lot of people succeed is if you can build a community or find a community of fellow deep learners you can meet with and study with on a regular basis. In fact, I hope that this Pine AI meetup that you're at right now will be a good place for you to meet these people. I hope you enjoyed the event today and that you learn a lot, both from the talks and from each other. And once again, welcome to the deeplearning.ai community.
Okay. Thank you very much, everyone. I will switch on my camera and also feel free, Bill and Grady, if you want to switch on your camera, and we'll kickstart. So I need to go back and share my screen. I will do some logistics in the background, so bear with me. Okay. Okay, so welcome everyone. My name is Rami Amar. I'm technical lead at IBM. I focus on hybrid cloud and AI, and my role is working closely with customers to maximize the value they get from IBM software, deploy the software successfully for the right business outcomes. I'm based in New Zealand as well, and I'm also ambassador for Deep Learning.ai, and I'm hosting the event today. This event is recorded for people who register to watch it later in their convenient time. I'll just move to the next slide where I'll be introducing my first speaker, Grady Booch, IBM Fellow. And just a very quick intro about Grady. That's from Wikipedia. Grady is a prominent American software engineer known for his significant contributions to the fields of software engineering and software architecture. He's best known for co-developing the Unified Modeling Language, UML, along with Ivar, Jacobson, and James Rumbaugh. UML is a standardized modeling language used to specify, visualize, construct, and document the artifacts of a software system. That's a Wikipedia definition, but I think we all know UML. Grady also originated the term and practice of object-oriented design and has authored several influential books and numerous technical articles on the subject. He currently serves as the chief scientist for software engineering at IBM Research, where he leads research and development in areas such as embodied cognition. In addition to his technical work, Grady also involved in a transmedia project called Computing, the Human Experience, which explores the impact of computing on humanity. He has also been recognized with several prestigious awards, including being named an IEEE Fellow, ACM Fellow, and receiving the Lovelace Medal. And it's a pleasure to have Grady today with us. I will also introduce my second and honor speaker to be with, Bill Higgins. So Bill is an IBM Vice President and Distinguished Engineer who leads watsonx Platform Engineering and IBM's open innovation efforts. As VP of IBM's watsonx Platform Engineering, which we'll be talking about it as well, organization IBM Research, Bill leads a team of experienced software engineers who, in collaboration with partners at Red Hat, build IBM's strategic AI platform components via contribution to strategic open source communities. As chair of the IBM Open Innovation Community, Bill guides IBM's 120,000 person global technical community to work better together and accelerate IBM's strategy through the power of community. Bill previously led the transformation of IBM's internal development toolchain, including the largest deployment of Slack and GitHub Enterprise in history. Bill graduated from Penn State University in 2000 with a bachelor degree in computer science. He lives in North Carolina with his family. So I would like to welcome Grady and Bill. It's great to have you with me today.
Happy to be here. Aloha, I should say. I'm on the island of Maui. And by the way, I love New Zealand. Been a long time since I've been there. Wish I could come join you all again.
Oh, okay. No, you're most welcome, actually. That would be good. I think it's not far from Hawaii, so yeah.
No, it's a close trip for me. Yes, or a long swim, one of those two.
Absolutely, great, and that's why I love, when I talk to you, you are very close to my time zone, which makes life easier for me. So that's great. So good to have you, Bill. How we're gonna structure this? So this will be more of I would say this discussion based on specific points that I'll be interested to discuss with you, Grady and Bill, today. So let's kick in. I will just go through slides and I switch off, and we're gonna have the camera so we can have better interaction. But I'll just start with first 3 slides. I'll just mention the points that I would like to talk to you, probably Grady, and also I would like to hear from Bill if he would like to comment as well. And then we can switch to other subjects and so forth. So the first 3 points I would like to discuss, Grady, with you will be the history of AI in the land of architecture. And what I mean here is, I'm coming from architecture background. I love architecture. I like to be the city planner and getting all the components together and build something. And with AI, it's very booming area. it would be interesting to see what the history is of AI in the land of architecture and where are we today. Also, the second point, if any thoughts you have around changes in architecture focus with the evolution that's happening in the AI space. And the third point, and that would be a checkpoint for us, is if you can also shed some light on rules-based and statistical architecture, AI, and the move to deep learning architecture. Does that make sense, Grady, or?
Absolutely, yes. So let's go way back in time, like to, I don't know, 200 BC, when we can speak of the Greek mythologies about Talos. This is perhaps one of the first instances we've seen the notion of the idea of there being an alternative intelligence. Talos was a clay figure, a golem that would walk around the island of Crete, if I'm not mistaken, throwing stones at any sailors who came nearby. Point being is that I think there's an element in human history that says to us, we believe that the mind is computable, although we don't really know how to do it. Back then, it was clay and some magical substance. These days, well, we're not quite sure what it is. Indeed, if you go back to more recent times, really the first era of what you could call modern AI came about with Newell and Simon in their approaches, which were completely symbolic in nature. Their logic analyst in particular was taking the ideas of formal mathematics and seeing if we could build laws around it that would yield what was then called intelligence. There was even Samuel, an IBMer from way back, who perhaps built the very first AI program demonstrable, which is a game of checkers. Very, very cool. It was mostly if-then statements, that kind of thing. But then it was very clear that there's only so much one could do with symbolic, say, systems in that era. And remember, this is long ago when we were dealing with pure algorithmic systems and was a lot known about building large complex systems. There were hints that there was something more. There were discoveries by some neurologists that indeed neurons were perhaps computable units. And so there was a little bit of effort in the late 40s about a thing called perceptrons. But as it turns out, Marvin Minsky kind of killed the idea when he recognized that the neural networks at that time were simply not sufficient to do Turing complete kind of things. So it literally killed that field for a while after McCulloch and Pitts had discovered this in the 40s. There was a bit of a winter, and then a realization that there's another way to approach this. And this was from my dear friend Ed Feigenbaum, who approached it from rules. This is the area of knowledge-based engineering. And one of the classic examples is a system called Myson. Folks like Campbell Soup even used it. So it did gain some traction, but there were limitations. If you started dealing with anything over a few hundred rules, it just simply didn't scale. So it too sort of fell to the wayside, and there was a bit of a winter. And yet, as researchers tend to do, there was still some interesting stuff happening in the background. Some interesting work with machines. The Lisp machine was born around this time, thanks to funding by DARPA. There was experimentation in massive parallelism, and thus the connection machine and the like, and the beginnings of algorithms that led to backpropagation. So here we are now. The foundations for modern computing, modern AI, were really set, I'd say, a couple of decades ago when we had a perfect storm, or the beginning of it. The discovery of some new algorithms, backpropagation in particular, the accumulation of large amounts of data, which particularly peaked in the last few years, for better or worse, thanks to Google and Facebook and Amazon and the like. And lastly, let's thank all the gamers in the world who had provided the initial need for GPUs. And Andrew Ng, just a few years ago, realized, wait, this is perfect for doing the kinds of matrix multiplication one needs for deep learning. And thus, deep learning was born. And that's where we are today. But I think there are some lessons learned in this, because like you, I look at the problem through the lens of architecture. And the fact that we have seen architectural styles over the years is actually a good thing, because this represents a vitality in the marketplace. And even now, although the marketplace seems to have been putting a lot of energy in transformer-based architectures, history shows us it is not the only way, as the Mandalorians would say. It is the way, but it's not the only way. There are multiple ways. And I think, at least where my head is right now, I'm encouraged to see directions, the direction of neural symbolic architectures, bringing them together. In fact, I'll close up here by saying this has been my focus. You mentioned I'm working in the area of cognitive or embodied systems. We did some work with NASA on their mission to Mars and basically built, thus you may notice the howl above my shoulder here. In my house, if you were to come here, you'd see it populated with a few robots. We were looking at building a neurosymbolic system that was in fact a HAL for the mission to Mars, minus the kill all astronauts use case, which NASA didn't seem to want. And I've been doing that for about 10 years. The last 5 years, recognizing that there are so many things we as a community don't know about AI systems, I've been working with a set of neuroscientists to better understand the architecture of the brain. And I'll close by saying, I do believe that the mind is computable. I do believe that we are sort of on the path for it, but we're still generations away. And honestly, it's pretty exciting to be part of that journey.
Okay, no, that's great. Thank you very much, Grady. I'm just trying to go back to the point. I think you covered them all, to be honest. But anything in particular around changes in architecture focus with the evolution of AI now? Do you see any changes?
Yeah, well, you've seen, again, over the decades, moving from truly logical symbolic systems to rule-based systems, now to deep learning systems. And the focus, of course, has been on transformer-based architectures. But even so, there are clear limitations as to what a transformer-based architecture can do. Don't get me wrong. I think large language models are interesting. There are some valid use cases. We know there are also some fundamental limitations. This may sound a little bit controversial, but I certainly am happy to back it up. Large language models are architecturally incapable of reasoning and understanding. And so we have to be careful because they are still statistical beasts. And they are, to put it politely, they are unreliable narrators. So one must be careful about using them. That doesn't mean we should reject them. We just need to be careful in so doing. And so what's been happening, I think many recognize the limitations. Jan in particular recognizes, of Meta, recognizes that there are limits to what large language models can do. And so he's also going in the direction of hybrid models, hybrid architectures. Moving just from transformer-based architectures, a mixture of experts is certainly a way to go. There are lots of different approaches in different kinds of training. And I think these are all valuable. But again, the fact that we're seeing this experimentation of architectures, I view as a healthy sign, because it represents, we haven't cracked the problem yet, but there's a lot of great people doing some really interesting things to try to get us there.
Okay, thank you very much. I want to
would it be okay if I just add a couple thoughts to that?
Yes, please.
Yeah, so another lens to think about that is actually putting AI in production. And so just, Grady gave some great, dates and numbers, but a lot of people, it's kind of arbitrary, but some people peg the founding of the field of AI 68 years ago in 1956 with the famous Dartmouth conference. And I was just doing some math as Grady was speaking. I started my computer science degree at Penn State 28 years ago, which is 40%, backwards. So it's only in the last year that a large number of companies and government entities have been trying to put AI in production. For a long time, it was more of a research field. And there were a small number of, pretty important entities, and Grady can speak to the history, that were trying to put AI in production, but it was very, very niche. And it was only with the, ChatGPT surfacing to a large number of people where the state of AI was, that last year was the year of experimentation. And it's really only this year that a large number of companies are trying to put AI in production. And putting AI in production is a very hard thing to do right now. And so I think we're really at the beginning of it becoming more of a mainstream thing versus a niche research thing. Grady, I don't know if you want to say anything about that.
No, respectfully, you're close. Because I would say it's true that in the last year or so, we've seen a multitude of companies rushing to AI, primarily to embrace large language models. But it's also the case that if you look past the last several dozens of years, organizations have been silently bringing AI in other kinds of models. We see it pervasive throughout financial organizations, using it as means of detecting fraud. We've seen it for facial recognition for literal decades now as well too. Check writing, looking for signatures in mail. This is also AI. But you know, that's a good sign because it represents that it has reached mainstream so much. That kind of AI is very much part of the atmosphere that people are breathing. So yes, I would say the difference is that it has reached sort of the public awareness because of the openness of what Sam and Greg have done with OpenAI. It's now available to everyone, and it's impacted so many different fields, especially the creative fields. And that's why we've seen this exponential rise of it. A lot of tire kicking right now, where time will tell whether or not many of those things turn into reality and sustainable systems.
Thank you, Bill. Thank you, Grady. I'll just move to another interesting point. So I'll share again my screen, and I'll be switching from time to time. Okay, so now you can see my slides. I wanna ask a question maybe to you, Grady and Bill as well. What else other than LLM? So LLM definitely is the big focus now, and everyone talks about LLM. But LLM is, I think it's a component. I think you and I, Grady, we talked about this before. So to you, Grady and Bill, if you guys want to shed some light, you know, what else other than LLM and where it fits in the architecture? I'm trying to go back to the architecture. Do you have anything to mention here, Grady?
Well, again, most visual things are still CNNs, convolutional neural networks. That's the basis of most kind of visual recognition things. And you'll see that again in the shadows. If you're looking at, you know, product placement or manipulating robotic arms and identifying products and things like that, those are CNNs, not LLMs, because the LLMs are primarily, not completely, textual in nature. And then we have the whole diffusion models, which is more in the audio and visual realm of really Gen AI. So it depends upon the kinds of problems you're trying to face. And I think, again, the good news is there are lots of these kinds of models out there, alternative ones, depending upon the modalities in which you're working.
Okay, cool. And Bill, feel free if you want to add to this one as well. Okay, cool. The next one I want to move to is extreme architecture experimentation. It's a very complex term, so if we can make it simpler. What does it mean?
I don't know.
Okay. Okay. Yeah. So this term we hear it a lot around extreme architecture experimentation, and I'm just wondering if we have any definition within the AI that can be explained in this area. If you passed by this before, Grady.
It's not a phrase I've heard much, but maybe it probably means the following. We're certainly seeing extremely large models with the size of weights that exist, and that's kind of cool. And if you talk about experimentation in this space, heavens, within the last 48 hours I ran across a paper where people are proposing doing inferencing but without matrix multiplication. They did some really interesting simplifying assumptions and are finding ways or exploring with ways to do inferencing without GPUs. And that's profound and deep, because we know that training in particular, inferencing less so, is computationally very, very expensive. And so while I'm running maybe 20 to 40 watts up here, some Congress people maybe less, we know that most large language models are consuming, you know, megawatts of energy. So there's something in there. So that's one area of experimentation, finding ways to do inferencing cheaper. That's pretty cool. The mixture of models I've described is an interesting one as well, where we're taking not just single large language models, but multiple ones of them and doing degrees of voting and the like. I would go back and say, if I, again, look at this from the lens of architecture, it is very satisfying to recognize that many organizations are rebuilding the central architecture of IBM's Watson. And if you sort of peel back the layers, Watson was not a neural architecture. It was purely statistical in its nature, but its secret sauce was that it was a pipeline architecture. You'd take an answer, you parse it, you would then explode it out into 10,000 or so possible hypotheses. You would then go across those hypotheses and search for evidence to support them, and then you'd rank them at the end. This is all through a pipeline. Seeing the same kinds of architectures beginning to pop out, especially with a mixture of experts, where you take a problem, you throw experts at it, and then rank them, very much like what Watson did.
Okay.
The original Watson, not watsonx that Bill works on.
Actually, Bill will tell us the story as well, maybe a couple of slides, and we would like to hear about what watsonx is and what Watson is, because that's another topic of the session today. Okay, thank you very much. Again, I'm trying to be really focused on architecture, especially with these slides, as you know, Grady and Bill. Now we're hearing about the multi-agency systems architecture, and I'm trying really to relate where I think software had very mature frameworks for architecture. We talk about object-oriented design, UML, maybe even under the TOGAF as well. There are many things when you do software architecture back then, until now as well. There is a process to do that. Now we're looking at the multi-agency systems architecture. So how we see this is evolving. Will that make things more complex or easier? Because people saying opinion that the multi-agency will make things perfect for enterprises, but is that correct? Or it is like when you talk about microservices, it's good, loosely coupled components, you can update, you can develop multiple languages, easy to maintain, but actually when you grow your microservices, you're stuck with a big mesh that you don't know how to manage it. So I just want to also hear any thoughts around the multi-agency systems architecture, and if we see any future around that. Will it be a hype, or that will be a good place to invest in? What do you think?
Well, I'm going to defer to Bill on this one. He's the guy on the front line every day pushing out real code. But my observation here is that there's one very important thing missing from this slide. You don't have any data scientists that are listed here, and they're an essential piece to the picture. And also no users, but I'll leave it at that. So Bill, I mean, you're under fire every day for putting out real stuff that matters.
Yeah, I'm pretty excited about the multi-agent architecture. And, I've been working long enough that I tend not to get excited about shiny objects. But the analogy I like to use for this is, if you've ever stayed at a really good hotel, they always have a really competent concierge. And you can call the concierge and say, hey, I'd like tickets to Broadway. Or you could call the concierge and say, I need to get some dry cleaning done before 5 p.m. And it'll get done. And it's not because the concierge is able to do everything, but they know how to delegate work to get work done. And so I think a lot of people had this mental model that there was going to be this one kind of galaxy brain model that did everything. But now, as people try to put AI in production in a company context where they don't have infinite resources, compute, or money, they realize that they have to make really important cost versus performance trade-off decisions. And so a nice thing about the multi-agent system is that you can talk to a sort of concierge worker who can then say, okay, given the task at hand, maybe I need to delegate to a code model, or a code model and a language model, or a code model and a language model and geospatial model. And so it can delegate to more specialized models who are highly tuned to get that particular task done. But it can also eventually will be able to make policy-based decisions on, I care more about performance than I care about cost. So maybe you get handed off to a bigger model that costs more, or you could go the other way. You could say, I really care more about cost than performance, and it's slower, but it costs less money. Or you could even get delegated to a model based on data sovereignty. Like, I really can only have this work done by a model in Germany. And so I think it's really going to be something that pushes things forward. And in some ways, Grady's probably laughing inside because we're just rediscovering modularity and composition, except in AI-based applications versus traditional software.
Yes,
yes.
I agree.
Software engineering is dead. Long live software engineering.
No, one more thing. I think we are at this stage when you say multi-agency or agency in general, agent, we still talk about assistant, right? No one is saying that I'll get a it will be the case that we are trying to replace the role of human being and having complete AI doing all the work. It's all about assisting and improving productivity. And maybe the repetitive tasks can be done by AI rather than human who can focus on innovation and creativity. Is that correct?
Well, let us hope that's correct. That there are some that would like to replace humans entirely. And indeed, you now begin to touch upon some of the ethical implications of what's going on here. This is a challenging problem, especially in the domain of warfighting. Should we allow autonomous weapon killing systems? And that's beyond the scope of our discussion here.
Okay, no, I agree with you. Controversial as well. So let's move to the next one. How to choose the right architecture. I'm not sure if you, Grady or Bill, want to add anything here. But like I said, it's an evolving area, and I think that's my opinion. We're missing frameworks still, design patterns. I would say it's an area that we're doing our best effort. I think the community is working on that, but because it's changing every second, and we're trying to catch up still, I think there are a lot to do around architecture. But I'm happy to skip this one. And before moving to watsonx and maybe hand it over more to.
Oh, actually, can I just say one thing on that?
Sure.
This is actually kind of a special one for me to talk about with Grady on the call because
Okay.
I learned a lot from his books earlier in my career. And I think a really fun thing for me right now is if you think about a book like, any of the patterns books like design patterns, those represent the accumulated knowledge of a set of folks who have solved problems together and discovered patterns that work. So one really fun thing for me is that in this phase where we're starting to see really broad deployments of AI into production, we're starting to recognize new patterns, like for instance, the retrieval augmented generation or RAG pattern. And so I think in the next several years, we're going to see this explosion of people discovering new patterns and then being refined. And 2 years from now, there will probably be a book called AI Patterns that document the patterns that have been found to work in production.
I like
Well,
that.
indeed, there's already a book called Machine Learning Patterns. So these things exist. So Bill, write us one of these. You need to do this.
Yeah, so I'm waiting for the AI version of polymorphism and inheritance and all these nice words that we're very excited about. But yeah, I agree with you, Bill. I think we should see a book where it's gathering all these patterns in a textbook. Yeah, that makes sense. Okay. Last before the watsonx topic is I think we talked before about training LLM with synthetic data. I'm interested more around the benefit and the risk that comes with it, because I think it's very good to an extent because clients can. Maybe I'll stop here. If you guys want to tell us what synthetic data is for people who are watching this, maybe people don't know, and what are the benefits and what are the risks for using it with LLM.
Bill, have you guys been using synthetic data in the training of watsonx? Because you have, of course, you have a variety of ways you're using to train.
Yeah, so the basic problem for people who aren't familiar is that if you look back at earlier eras of machine learning and AI, one of the gating factors, if not the gating factor, was the human labeled data that was used to train the model. Simply put, if you need gigabytes or terabytes of training data and you depend on humans to craft that by hand, it's just too expensive. And so the systems that were successful with AI prior to foundation models were the companies like Google, who could automate that through the collection of data for their massive web properties like Gmail, or with Facebook, the Facebook app, et cetera. And so one of the things that has really helped in this modern era is the use of synthetic data to create large amounts of viable data to train models. And one technique that we've been using is we have an open source project called InstructLab. And what you do with InstructLab is humans submit, say you're Grady Booch, and you ask a large language model something about a topic where you're an expert, like software architecture, and you think it gives you a poor answer. So what you can do with InstructLab is provide a few examples of what you consider good question answer pairs. And then what it does is it consults a much larger model to generate more examples of similar question answer pairs that can then be validated and brought back to the smaller model to make the smaller model smarter. So you kind of bootstrap from a small amount of human data to a larger model to generate large amounts of synthetic data. to then customize the smaller model. And so it kind of seems like a bit of voodoo, but it really does work to produce better models. And then the next time Grady asks the question, he should expect a better answer about the topic, where he gave it just a modicum of human curated question answer pairs.
Yeah, I love it.
And I'd add to that, Bill, that there's sort of an existential crisis that the larger companies are facing, and that they're running out of data. And so synthetic data is a way for them to fill the gap. There's one domain that I've been working in, what I found particular value in synthetic data, and that's in the area of code assistance, because building new data for, how do you program this is actually relatively easy. And furthermore, there's a significant ground truth that you offer it some synthetic code, and it either works or it doesn't, and you can know that fairly quickly. So as a result, you can get a large volume of high quality sort of self-labeled data that continues to train these things.
Well, thank you very much, Grady, and I agree with you. And Bill, I love the fact that you mentioned an Instruct Lab, which again, maybe some people will be watching this not familiar with it. Maybe an event in the future with yourself and someone from Red Hat as well, where we can talk about what Instruct Lab is and what it does and its the value, because I personally believe it's a very good product in the era of AI. So yeah, thanks for mentioning that. And maybe that's a good segue, Bill, to AI and hybrid architecture deployments, IBM strategy. We all work for IBM, and yeah, you're leading the watsonx strategy for IBM in research. So if you could just shed some light about, what IBM doing in terms of the two pillars, the M1, M2, the Mission 1, Mission 2, and where, watsonx fits into that, because that will take us to the next slide, would be great.
Yeah, so if you look at the rise of cloud computing, which, maybe we can date starting with 2006 with the early AWS services, there was this hope that you could get out of the business of running data centers, and things could run in the cloud, and it would be much more scalable, bursty, on demand, et cetera. But by the late 2010s, what almost every company found was that they had not migrated all of their applications to a single cloud. They had migrated some applications to, let's say, Azure, some applications to AWS, and some applications to Google. And then there were some applications that they could never migrate because of the cost of migration, and some that were running on environments like the edge. And so people ended up in a situation where they were in a hybrid cloud situation, not by design, but just because that's the way it turned out. You might have a very thoughtful strategy about moving everything to AWS, but then you acquire a company who is all in on Google Cloud. And so in 2018, IBM really decided to take this problem head on, rather than just telling the customers, you figure it out. And so we acquired Red Hat because they have a platform called OpenShift, which is an enterprise version of Kubernetes that's designed to really work on any cloud, on premises or on the edge. But it really focuses on cloud workloads. Back in 2019, it did not focus on AI workloads. So the strategy back then was that let's help everybody have a more intentional approach to hybrid cloud by having this common OpenShift platform, but let's lay the groundwork for running AI workloads in a hybrid manner. So starting in 2019, we took a look at what was called the Watson technology of the day, and there were really two big shortcomings relative to that strategy. The first one was there really wasn't a Watson stack. Watson was a label that pointed to 20 different stacks that did different things and had different architectures. The other thing was, in the 2010s, the premier Watson services had been designed with the assumption that they would only run in the IBM cloud. And so between about 2019 and 2022, we did the hard architectural work of making the AI platform technology portable to run in any cloud. But then we did the even harder work of getting all of the different IBM teams to work together and start contributing to a common stack. Probably unsurprising, the cultural problem was much harder than the technical problem. But by 2022, we had gotten to a common stack. And then the IBM and Red Hat leadership team made a decision that we should open source that common technology. And then it became a new layer on top of OpenShift called OpenShift AI. And the really nice thing about it is it really encapsulates everything that the Watson teams of the 2010s learned about running AI at scale in production for enterprise scenarios, and made it available as a set of open source projects, both open source projects that IBM and Red Hat created, as well as deciding we should contribute back to popular open source communities started by other people, like, for instance, PyTorch from Meta.
Excellent. Thank you, Bill. And I want to move to the next one, which I think we covered the open source, but I'm going to IBM watsonx. For someone, I will take the IBM hats off. So I will ask questions that you might say, why are you asking these questions? You should know already. But for someone that perhaps doesn't know anything about watsonx and asking a simple question, so you IBM doing AI and generative AI, how watsonx or watsonx.ai is different to ChatGPT? Because in people's mind, especially in consumers and many people, they know about the ChatGPT, and like Arvind, our CEO, said, ChatGPT did the Netscape effect for browsers back then. So in people's mind, if you want to explain something to me in AI, how you compare it with ChatGPT, and we talk about watsonx, we talk about watsonx.ai or watsonx.whatever. So on a high level, and we can have a further session in the future about detailed architecture, but just on a high level, what is watsonx compared to ChatGPT, and what's watsonx.ai versus .whatever? Can you just tell us a brief about that?
Yes, they're kind of different categories of software. ChatGPT is an application that is really meant for users to use it. I mean, sure, it's got APIs and you can work with it as a platform, but it's fundamentally an application. And so what watsonx provides is the lower level layers that allow you to create your own applications, your own AI infused applications, whether that's a chat application or a very different application that uses AI. So for instance, when you ask a question to a chatbot, whether it's ChatGPT or anything really, it's going to have to go through what's called an inference server. And so nobody except OpenAI knows how inference works with ChatGPT, but with watsonx, we have an inference server that's based on a really high quality open source project called VLLM. And so one difference is that all of watsonx, the underpinnings is open source. And so you have that kind of safety of using open source versus being locked into a proprietary platform, the ability to inspect the code and even contribute back if you want to. So the main parts of an AI system, the runtime parts, like I'll set training aside for a second, it's fundamentally about inference, and it's fundamentally about customization, which is commonly called tuning. And so the things we really try to work hard on is to make sure that our inference system is high performance and portable, so that it can scale up to internet scale workloads, but scale down to edge workloads. And again, everything is open source. And then with tuning or customization, when you first get an AI model, it's sort of like hiring a new employee. They may have some general knowledge, but you really have to train them about how to do the job you're hiring them to do well, so that they can do it well and with good performance. And with tuning, there's this whole kind of explosion of innovations with different techniques. And so what we try to do is to provide a common set of abstractions, so that as the state of the art with tuning advances, you don't have to rip everything apart every 6 months, but rather you can count on IBM to continue to advance the tuning technology while we embrace and contribute to the state of the art.
Thank you very much, Bill. That's great. And that takes me to the last slide around watsonx before I move to Grady about another interesting topic. We as IBM, we talked a lot about foundation models, but I'm sure that not everybody will understand what foundation models is. So do you want to just shed some light about foundation models in the context of watsonx.ai?
Yeah, I think Grady talked about it at the very beginning of the chat when he was talking about the history of AI. And so I think it was 2017, Google wrote a paper called Attention is All That You Need, which introduced the transformer architecture. And what it really did, and this is a gross oversimplification, is it made the underlying model much more reusable. So it used to be that you'd create an AI model that did one very narrow thing, like maybe it did sentiment analysis in English. And if you wanted to do sentiment analysis in Spanish, well, that's another model. So with foundation models, as the name implies, you could do a very large number of tasks with the same underlying model. Now, that underlying model might cost millions or tens of millions of dollars to create, but once you have it, you could use it for many things. And then the other real advance with foundation models, and I'd love to hear what Grady thinks about this, is the ability to use semi-supervised learning to train them. So a few minutes ago, I was talking about the problem of if you need human labeled data, you're going to be fundamentally blocked. Whereas with semi-supervised learning, you can take literally text from the web or from books and have the model in a fairly automated way get smarter by looking at that data that you've just pulled down. The last thing I'll say about foundation models in watsonx, and this is something I'm pretty proud of, when we started watsonx, that was early, well, when we started the productization of it was early 2023. And at that point, there was this mental model that everybody had, was that there would be one model to rule them all. And, everybody would just use GPT-4. And we really had the strong belief that there was going to be this explosion of innovation with models, especially with open source models. And so we designed watsonx from the outset to be really good about existing in a multi-model world. And now we support so many different families of architectures, and you can see some of them there: Llama, Mistral, Granite, etc. And we're adding more every day.
Excellent. And Grady, do you want to add anything to this?
Bill nailed it.
Okay, cool. Then we move to the next slide, and we'll be interested to hear from you, Grady, and also Bill, if you want to add to that. But risk of superintelligence. So remember, I think you remember, Grady, that 7 years ago, probably, I can't remember, you talked about superintelligence, but ChatGPT and GenAI and this big bang that happened last year wasn't happening at that time. When I was watching, I was saying to myself, and just to give context, people can go to YouTube and search for Grady Booch TEDx talk, and he was talking about superintelligence. And I was thinking, back then I didn't feel like people are really worried that AI will take our jobs and will be a threat to us, but I can feel it now, but maybe that's only me. So many people are really worried, and that's becoming real, Grady. People really worry about their work, about their job. I have to say that I can see people are losing their jobs because of AI. It is reality. I'm not saying any bad news or sending any negative energy, but AI and automation in general, it's not only the AI, it's the automation aspect, is really making impact. So is there a bigger risk on a human being from super intelligence?
Well, the introduction of every technology disrupts the labor market one way or another. We have far fewer people who are in agriculture these days. And that's probably a good thing, because a lot of the agricultural jobs, although meaning can be found in such jobs, they change civilization, certainly change cultures, and allowed people to go off and do other things perhaps we're better suited as humans to do. And I think the same thing is true with the AIs we have here. The TED talk I gave, gosh, a decade or so ago, was really based upon Bostrom's first book, Superintelligence. And I was a little bit annoyed that Bill Gates and Elon Musk and even Stephen Hawking were all over it saying, oh, yeah, this is real. And it's like, I decided to do a TED talk that said, love you guys, but you're so profoundly wrong. That I do not fear superintelligence. I fear the power of the organizations who believe they are trying to build superintelligence, and it's a greater existential risk for us. Again, as I said, I believe the mind is computable. I believe we are generations away from getting there. And so my P-doom, as people call it, my concern or my belief that AI and deep learning in particular will destroy humanity is pretty close to zero, if not a negative number. I just don't worry about it. But that being said, there are clear and present dangers associated with this technology. There are inherent biases in the models with which things like ChatGPT have been trained. We at IBM have tried to be very careful in the generation of Granite to ensure that those kind of biases are simply not there. But yet they persist, especially in a lot of the larger open source models and some of the private models as well. We also know that the application of them has some challenges relative to copyright. There are multitudes of lawsuits going on right now with many of the diffusion models. A recent one in the last 24 or 48 hours by major record companies going after a company that produces an AI that generates music. So these are, again, clear and present dangers because they are, in effect, stealing the intellectual property and the creative property of humans without compensation. Whether or not that's a legal issue, I'm going to leave it to the lawyers. Whether or not it's a moral issue, well, I think it's pretty clear that we have to be careful about denying or diminishing the humanity that we have before us. So again, I'm not worried about a superintelligence. I'm more worried about the organizations that are trying to control the superintelligence. And I'm more concerned about the clear and present dangers of the bias and risk of applications of these systems.
Yeah, thank you very much. One maybe before the last, AI tools. A very simple question to you, Bill and Grady. If someone is looking at this and say, AI is big, complex, huge, what I need to learn? So we're talking Python, PyTorch, TensorFlow, with what I need to learn if someone is starting their career, or they are already SME in IT, but they don't know what tools they want to focus on. Is it LLM ops? Anything around tooling that people can focus on? Because one purpose of this events that we run is for people to get some thoughts about how can I keep my skills relevant to the market. So do you have any suggestions or coaching for the people who will be watching this?
The short answer I'd give is, what do you want to do when you grow up? I'm still trying to figure out that myself because there's so many possible paths. I will observe that there are going to be far more people who will integrate AI models into their systems than people who will be building their own models. So while it's fun to go build an LLM from scratch, you're going to be competing with the huge salaries of the folks at Google and Amazon and the like. And if that's what you want to do, go for it. But far more of us who are in the trenches are going to be taking these systems and trying to integrate them with existing systems. As a result, I think the good news is that means that if you've got some good development chops now, moving into that domain of integrating these things, you're going to be a leg up over people who don't have those kind of chops. And the good news also is there are lots of free courses available in this space. So short answer is it depends upon what you want to do or where you want to go.
Okay. Thank you.
Yeah, I'll just add to that. I'll quote Grady so he doesn't have to quote himself. So one of Grady's most famous quotes is that the entire history of software engineering can be seen as one of rising levels of abstraction. So to Grady's point, if you wanted to use machine learning in a production system 10 years ago, you had to be a pretty hardcore data scientist. These days, you can literally download a model off of Hugging Face and then use something, like the RAG pattern and other open source tools to very quickly have a highly functional AI use case implemented in your existing application. And so I think because of that rising level of abstraction, it's just going to become much more accessible. And the people who have to get into the hardcore machine learning, neural network design, data science will become much more niche. Like there's people today who work on compilers, but most people don't worry about compilers.
Well, okay. No, that's a good point, Bill. I agree with you. Okay, good. Last but not least, one thing about this, I think we had a discussion before, Grady, and you mentioned something I found interesting. When I said with all this code assistant, I'm trying to make the language relevant to people who are watching who don't know what code assistant means, but like the GitHub Copilot from Microsoft, or any GenAI tool that helps developers by generating code with prompts. Some developers will look at it and say, come on, I say, can you write for me a program that can do blah, 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 and here you go. All the code been written for me. They will get rid of me and I won't have job to do. And software engineers, they love software. But you mentioned one thing that you said, AI, they know nothing about design. So from your perspective, and you're here, you can correct me if I'm wrong, while the code assistant software can help improve productivity, but still the human being will be relevant in the process, because the software design aspect is something that still the human need to do in terms of taking design decisions. Or maybe soon, in the next 5 years, we'll see the AI will do the design decision themselves.
Well, I found that many of the coding systems are faster than looking things up on Stack Overflow. So there's that. For me, it's been kind of like having a a junior developer next to me who can do some of the grunge work that I don't want to have to do or reminding me of things. I've not found it to be the level of any of the code assistants that I've encountered yet who rise to the level of being a good pair programmer. But they're a nice crutch along the way, and so they're not going to replace thinking or creativity by any means.
Okay, cool. Last one is too many terms here, right? Super intelligence, AGI, artificial generative intelligence. What's the difference, and are they the same thing? And are we close to AGI or not? So can we explain what AGI means in that context?
I'm not a fan of the term AGI itself. It's kind of like the word singularity, that I think its primary value is it's useful for making clickbait headlines and selling books and doing lectures, because it's kind of this vague thing. There's no objective definition of what AGI is, although a few have tried. Francois Chalet in particular, I think is on a right path. He's written this great paper called On Intelligence. He's been proposing of late that there's a series of conceptual tests that one might use to see if whether or not a system is super intelligent. I think it's sad and ironic that you go back to Turing's initial paper about computing, that his litmus test was whether or not we could build a machine that could deceive us. So I guess deception is a part of being humanity, of being human. So AGI, I'm a little bit concerned about using the term because it's a suitcase word. It means so many things. It's so emotional. What I can say is that there are, on the one hand, far too many people who have believed that we have AGI now. We're a long way from it. But then Elijah also fooled a lot of people. But I also know that when we get there, we'll see it. But it probably has something to do with the ability to look at novel situations that have never been part of the training and be able to apply reasonable approaches to it. And then furthermore, to not do that for just one domain, for just multiple domains. That's the nature of what general intelligence means for us and as organisms who have lived. So again, it's a difficult phrase and it's a problematic one. So I tend to, not worry about it.
Thank you very much, Grady. And apology that I didn't take any question. While I'm doing the closure, if someone has a question, you can post it in the chat. But yeah, we don't have time for that. Apology. But anyway, just for the people who are watching, or will be watching as well, you will receive a survey for this event. And deep learning with AI is giving some promotion code about courses in Coursera. So look at it. This is recorded to be sent to you as a link so you can watch it. If you're already registered for the event, you will get it. And also you can follow me on LinkedIn. I'm just putting my how to search me on Google, Rami Amer IBM. I can put my email address because it's a very public forum here. And definitely the speakers, you can follow them on LinkedIn. You know their name already. But I want to leave it here, and I want to thank you very much, Grady and Bill. Really appreciate your time. And we'll be looking for maybe more in-person events or online events about other specific topics. But I would like to thank you very much for your time.
Aloha, everyone.
Thanks for the opportunity.
Thank you very much. Thank you. Bye-bye.